Hello guys, welcome to all of you in Code T Point. My name is Amit and in this Python learning series, we are going to cover assignment operator. So what is assignment operator? So you can say if we assign or if we give any value to a variable and then we assign it through the assignment operator which is equal to, that is called a assignment operator. And we can use the various other operators and do the combination of these operators and we can apply the various operations. So let's say in assignment operator, if we are going to apply arithmetic operators, which is additions, subtractions and so on. So if we do the combination of these two part, we can have like additions and assignment operator, multiplication assignment operator, division assignment operator and so on. So let's go and start writing the code. So in Jupyter Notebook, I'm going to start with assignment operator. Assignment operator. So in this case, let's say I'm going to take one variable a equal to 10. Okay. And in this case, the equal to sign is called assignment operator. Now if I'm going to write print a, so obviously it will be return as 10. So now let's go and start doing the combination of this operator with other operator. So if we can do, or if we can perform this operation a plus equal to, let's say I written 5. So it means a equal to a plus 5. It means that is the value of a is getting incremented by 5. So the previous value was 10 and now it has been incremented by 5. So the next value should be 15. Correct? So let's go and do it. Correct. So now you can get it is okay. So since we have done a plus equal to 5 and then again we did a equal to a plus 5. So which is both are the same. So in this case, what I'm going to do is I'm just commenting this third line. So what you can do is you can just put so line number and you can get the line numbers. So I just commented out line number 6 and then I'm executing this piece of the code again. So you can get is 15, right? Now let's go and do it another, operation a minus equal to, let's say 3. So what will happen? This time the value is getting decreased by 3. So previous value was 15 and now it will get decreased by 3, then we will get the values 20. 15 minus 3 equal to, 15 minus 3 equal to 12. Correct? So in this case, we will get the value is 12. Correct? Now go for another part is again, if I'm writing a multiplications and then assign then assignment operator. So let's say in this case, I'm just putting 5. Now again, I'm just doing the print. So you will get 12 into 5, which is 60. Similarly for division operator. So a divide equal to, let's say this time 3, and then we will write print a. So we will get 20, correct? So can anybody tell me in this case, if I'm going to write, double division, or you can say in this case, we can write, let's say 2. So what is meaning of this 2? So this part, particularly this one, will return us a integer quotient. And integer quotient, that means the value which we have right now is 20. And if we divide 20 by 2, then the integer quotient will be remain is 10 and it will return us 10. So let's say instead of 2, if I will divide it by 3, then what should be the integer quotient? That it should be 6 because it is not completely divisible, right? Now I can say print a. In this case, what you will get 6. Again, if I am going to write modulus, with assignment operator. So A modulus, let's say this time I'm going to write 2, modulus equal to 2. So what will happen? 6 will be divided by 2 and it will give us remainder. So I'm going to write print A and you can get remainder which is 0. So because 6 is completely divisible by 2. Now let's say if I'm going to take one more example over here, or let's say in this case if I'm going to write 4. So what will be the result? The remainder is 2. So let's say in this case what I'm going to do is, if I'm going to use like double star, and since double star will be give the exponent operations, and in this case what I'm going to do is I'm going to use it A double star equal to 3. So and then what I will do is print A. So you can check what will be. So it is 2 to the power 3, that means 8, correct? Similarly, you can perform other operations by applying the assignment operator, like the bitwise operators and so on. So look into these are the operations. It will be helping us to understand that by combining the different operators, we can perform certain tasks, and it will help us to do the lot of operations. So again, in this case, what I'm going to do is I'm just using one more example over here. So let's say in this case, I'm just taking one is A is 100. And in this case, I'm just taking B is equal to, let's say 2.5. Now, in this case, if I'm going to do A, let's say this is I'm keeping 100.5, and this time this is I'm keeping is 3. And in this case, what I'm going to do is A plus equal to B. Then can anyone please tell me what should be the value? In this case, what will happen? The value of A will be incremented by B to the power 3, and B to the power 3 will be how much? It will be 81, because 3 to the power 3 will be it should be 27. I thought it is 4. I'm so sorry. It is 27. So the value of A will be incremented by 27. The value of A is 100.5 plus 27. Then the value should be 127.5. So let's see how much we are getting, correct? So this is how we can perform different operations. In this today's session, we are going to cover bitwise operator, and we will write the code how it actually works. So what is bitwise operator and what are the types of the bitwise operator? In the bitwise operator, what it does, it converts the values in the form of binary and then it performs the operations. So you can say whatever the value we supply to a variable, it converts into the binary form and then it performs the operation on the bits. So there are 6 types in bitwise operator. First is bitwise AND operator, bitwise OR operator, bitwise NOT operator, and bitwise XOR operator. And fifth is, you can say, bitwise left side operator and bitwise right side operator. So we will go and see how we can understand these are the subcategories of the bitwise operator. Okay, so let's go and start writing the code. Okay, so in bitwise operator, it can represent through the ampersand sign. So let's say I have written A and assigning the value to this variable is, let's say, 5. Another variable I'm taking is B and I'm assigning a value, let's say 3 to this variable. Now what I'm writing is print A ampersand B. So it means it will perform the bitwise operations of AND. And executing this piece of the code, what we are getting? 1. So let's go and understand it, how we got 1. If we find it out, like what is a binary value of 5, okay, so let's go and find what is the binary value. So go to your Chrome browser, and this time I'm writing binary value of, let's say I'm writing 5. So binary value of 5 we are getting is 101. All right. So I'm going to write over here is 101, and binary value of 11 is 011. You can see and you can search in Google. Now, in this case, what is happening is, now we'll perform the operation on these bits. So what is happening is, in this case, if the bits are different, like if the bits are different, then it will be 0. If bits are same, then it will be remain same. So for in case 1 and 0 will be 0, 0 and 1 will be 0, and 1 and 1 will be 1. So 0, 0, 1 will represent a bitwise representation of 1, and that is why we got the value 1. So let's go and understand this piece of the code over here. It is, let's say I have written like 101 for 5 and 011 for 3. So 1 and 0 will be 0, and 0 and 1 will be 0 again, and 1 and 1 will be 1. So in this case, wherever the bits are different, okay, it is 0, and whenever the bits are same, it will remain the same. Either it is 0 or 1. So in this case, it is showing 1, correct? Let's take another example. This time, again, I'm just taking a small number so that we can understand it better. So let's say, again, I'm just taking a value called a equal to 3, and this time b is equal to 2. Okay. And let's say we are going to write print a ampersand b, and in this case, executing this piece of the code. So what we are getting is 2. So I'm just writing here, in case the value is 0, 1, 1, and in this case the value will be 10. Okay. So what we can do is 0 and 0 will be 0, 1 and 1 will be 1, and 1 and 0 will be 0. Okay. So it will be 10. So, and 10 is a representation of 2, and that is why we got the value 2. So this is bitwise AND operator. Okay. So let's go for bitwise OR operator. In this case, if I'm going to write bitwise OR operator, I'm going to write bitwise OR operator. In this case, what I'm going to do is, so let's say I'm writing print a and bitwise OR operator, which is vertical line, and then executing this piece of the code. Okay. So what is happening in this case, whenever the values are different, okay, whenever the bits values are different, it will be 1. At least if one bit is 1. So let's say in this case, what I'm going to say, A is 011, B is 010. So if we are going to apply OR operator, in this case, what will happen? 0 and 0 will be 0, 1 and 1 will be 1, and 1 and 0 will be 1. Previously it was 0, but this time it will be, if the bits are different, then it will be 1. At least the value will be, one value will be 1. At least one bit will be 1. In this case, you can say 0 0 0 1 1 1 and 1 0 1. So that is why it is representation of 11, and 11 is a representation of 3, and that's why we got the value 3. Correct? So this is bitwise OR operator. Now the third category is bitwise XOR operator. In this case, what will happen? So let's say it is representing in the form of A and cap B, and let's execute it. So what we are getting? In this case, we are getting again 1. So what is happening over here? So let's say we are trying to understand this part. 0 and 0 will be 0. 1 and 1 will be 1. And 1 and 0 will be like 0. So please understand that is in the bitwise XOR part, if the bits are different, it will be 1. Sorry, if the bits are 0, if the bits are different, it will be 0. If the bits are different, it will be 1 for OR cases, and for XOR cases, it will be 0. Right? And that is why it is saying in this case 0 and 0 will be 0. 1 and 1 will be 0, and 1 and 0 will be 1. So that is why here the value will be, you can say whenever the bits are different, it is behaving like a 1, and if the bits are same, it will be 0. If the bits are different, it will be 1, and if the bits are same, it will be 0. So 0 and 0 will be 0, 1 and 1 will be 0, and 1 and 0 will be 1. And that is why you got the value 1. Okay. So this is a bitwise XOR operator. Next part is bitwise NOT operator. So let's go in this part. NOT operator. In this case, what happens? It is going to convert all the bits into opposite bits. If it is a 0, it will be converted into 1. If it is a 1, it will convert into 0. So let's go and we will write. And representation of NOT operator is in the form of tilde. So if I'm writing tilde, so what it does, it flips the bits and changes the sign also. So I'm repeating once again. In the NOT operator, it changes the bits. If it is a 0, it will be 1. If it is a 1, it will be 0, and changes the sign also. So that means it is a flipping the bits and changing the sign. So in this case, the A, which is 3, and 3 is 0 1 1. So that means it will be representation of the form of 1 0 0, and the sign will be minus. So 1 0 0 will be binary form of 4, and since the previous value is 1, so in that cases the flip sign will be changed, so it will be -4. Okay, so you can say this is a 0. First case will be 0. So if you change the 0 to 1, it will be 1, 1 to 0, and 0, and 1 to 0. So 1 0 0, and sign will be negative. So it is 100 is representation of 4, and that is why you are getting the value is -4. Next part is bitwise left operator. So let's say if I'm going to write, in this case, print A, in this case, my bits is going to shift towards left by 1. My bits is getting shift, bits are getting left shifts towards 1. Okay. Sorry, in this case, I'm so sorry, it is right shift. I'm so sorry, it is right shift. So for left shift, if I'm going to write, it should be 1. So in this case, if I'm writing print A left shift to the 1 place, so that means my bits will be shift towards left by 1 place. So if I'm going to execute this piece, it is showing 6. So let's go and understand this piece of the code. So let's say I'm going to write over here, A is, again, A, what we are writing, A is 0, 0, 0, 0, 0, 0, 1, 1. Okay. So this is 8-bit. In this case, what we are going to do is, we are going to shift by 1 place towards left. Correct? So that means the value, next value will be, if we are going to shift towards left by 1, so that means whatever the empty place will be created, it will be filled by 0. So 0, 0, 0, 0, 0, 1, 1 and 0. Right? Correct? And it will be representation of 6. Okay. So let's say if I'm going to use this piece of the code and try to understand what is the representation of this one in the form of integer. So what I'm going to do is, I'm just putting over here print, and inside this I'm going to put this number. Okay. And then I'm putting into 2, and let's execute it. Let me put it in A equal to those number. Correct. And then I'm going to use print A comma 2 and executing. Okay. So here it is, you can say this number. Okay. So there is a 2-way to identify from binary to integer and integer to binary. So either you can use format function, or either you can use some other functions which is in terms of binary to integer by creating the if functions. In this case, what we are trying to do is, if you just taking this is a number 110, so simply you can test it out. 110 is a representation of which binary number? The binary of 6, or either you can say simply is binary value of 6. So let's say, sorry, it's a 5, binary value of 6. So what we can get it? The value is 110, which is, you can say here in the form of, that is why you are getting the values 6. Right? Similarly, if I am doing it bitwise right shift, so if I am going to use A right shift by one place, it means whatever the bit value are there, it is going to shift towards right by one place. And whatever the missing space will be created, it will be filled by 0. So now, in this case, what will happen? This number is getting shift towards right. So what we will write? It is 0, 0, 0, 0, and again 0, 5, 0. Now it is 6 and the value will be 1. Okay, right? And since a left place one space is created, then it has filled by 1. So let's say if we represent or writing this piece, then what will happen? It will be, now let's go and execute this piece of the code. So what we are getting? 1. So because it is representation of 1, correct? So you can understand the bitwise left shift operator and bitwise right shift operator. So this is all about bitwise operator. So you can understand that is how it is work. So please go through this part, and if you have any challenges, feel free to comment it out and I will try to respond it out. Hope you will enjoy this session. Thank you. Thank you once again, guys.